Hello guys, welcome back. My name is Dict. By the end of this class, we're going to know different data types in Python 3. Every value in Python has a data type. Thus, a data stored in memory can be of many types. For example, a person's age is stored as a numeric value and his name as a string. Python has 5 standard groups of data types, which are numbers, sequences, sets, and dictionaries. And at this point, I want to mention this. All Python 3 data types are classes. By this implication, they have methods. Now don't ask what classes are and what methods are. We have videos dedicated to them as we go down the video series in this playlist. Under numbers, Python supports 3 different numeric types, which includes integers indicated with int, floats, and complex numbers. So we'll take them one after the other. Integers are positive and negative whole numbers, including 0, as indicated on the diagram on the right hand side. I'm on Python 3.7.4 shell, as you can see, and here I have a prompt. If I type in front of this prompt n1, which is the fixed number, then I will assign it onto 20. Now I have n2 assigned onto number 11, for example, and I have n3 assigned onto 0. If I type on my keyboard, I open and close my parentheses inside, and now reference n1. When I hit enter, it gives me class int. So if you really want to know the class for a particular data type you typed in Python, you use this type function. Then you fill in the object reference in between, or the object itself. Alright, so you see that n1, which is 20, is of class int. Now if I go ahead and maybe reference something else, here I said of what type is the number n2. It's of class int as well. n3 is just 0. When I close my parentheses, I say n3. See that they are all integers. So an integer is a positive or a negative number including 0. For example, if I say type, then in my parentheses I fill in a negative number like minus 10, for example, and I hit enter. It's still int. So whether it's positive or negative, it's of type int. Alright, so the second one is the floating point numbers. Python's float data type are decimal numbers. Alright, so if I go ahead and just fill in the values direct, I'll say, okay, of what type is this data? In brackets, I'll fill in maybe 0.8 and I hit enter. You see that is of class float. That means it's a floating point number. If I do the same thing for a negative number, a negative decimal number like minus maybe 9.5 is a float as well. Even if I do this might interest you. Type, I open my parentheses, I close, I say 0.0, and it's telling me it's float. So you see in Python, 0 is not equal to 0.0. In float, sometimes in Python, it might optionally find e or capital letter or small letter e followed by negative or positive integer. So they use this for scientific notifications. For example, if I do something like this, type, I open and close my parentheses, and in between I do something like 0.443. You see, it's a floating point as well. I open and close, maybe point, I think 6E3 as well. It's a floating point. So inquisitively, if I try to print it out and see what it looks like, if I want to print out this number now, so 0.6E3, okay, see it's 600.0. So the last data type under numbers is the complex data type. If you've been taught complex numbers before, you will agree with me that we have the real part and the imaginary part. So the syntax for complex numbers is the real part plus the imaginary part, then you append a j to the imaginary part, as you can see on the diagram on the right hand side. I will type let me say A. I will assign it onto this value now, 2 plus 3j, and I move down. Nothing happens. And here, if I say I want to see the type of this data I just assigned onto the variable A, now you see that it's giving me complex. That means it's a complex number. Of course, the 2 here is the real part, while the 3 appended to j is the imaginary part. Okay, so Python even have this way of identifying the real part and the imaginary part. Let me do something like this. I'll assign now, let me say A1 is equals to 5, and I move down. I say A2 is equal to, let me just call it 7j, and maybe at a point I say, look, if I add this, I want to see the type. I want to see the type of A plus B, and I say enter. No, it's a mistake, sorry, not A plus B. So type, I open and close my parentheses, A1 plus A2. Okay, I hit enter. Fine, I have it there. So it says it's a complex type. Alright, because Python sees this A1 as the real part and A2 as the imaginary part, because it has a j appended onto 7. So that is complex numbers for you. Now we'll move on to sequences. Under sequences, we have 3 inbuilt data types, which includes strings, the tuples, and the list. Now, strings are represented by str data type, which holds a sequence of Unicode characters. A string literal can be created using either a single quote or a double or even a triple quotation mark. So if I do something here, of course, if I do this, let me say x1, x for string, I assign it onto single quotation mark, then here I would say decay, and I move down, nothing happens. And if I want to check the type of the data I just inputted, I say type of x1, it says a string, which is xtl. So xtl means string data type. Okay, so this same thing, if I say x2, and this time I use double quotation mark and I have decay in between, it's still nothing happens. And if I check the type, okay, of x2, it's still a string. So if I just go ahead and check the type of x3, this time I want to use a triple quotation to 3, decay like before. So if I move down and maybe I check, you say it's a class string as well. So a string, you can use single quotation mark, you can use double quotation mark, you can as well use triple quotation mark. So the next one is the tuples. A tuple is an ordered sequence of 0 or more object references. To create an empty tuple, we use an empty parenthesis. So if I have, let me say T1, T4 tuple, and I set it equal to just an empty parenthesis, and I move down, I want to see the type of data I just created. So in between, I fill in T1 and I hit enter. You see that it's a tuple. So there is nothing inside. So what we created here at this line is just an empty tuple. And you can see it's of class tuple when I hit enter. And I want to create a tuple with a single or multiple item. I will do it like this. Let me say this should be T2 now, and I equate it onto double quotation mark. I would say maybe 1, then I separate with a comma. So what I created now is a tuple with 3 items, 1, 2, and 3. Okay, so here if I check the type of the data I just created, I fill in T2, you see that it's still a tuple. And maybe if I decide to print it out, you see what it looks like. I'm printing out T2. So I have 1, 2, 3 in parentheses. So that simply means you can still create a tuple using parentheses. So instead of referencing it this way, I think the standard way is using parentheses. So if I create another one like T3, equal to this time I open and close my parentheses, then inside I fill in the values, and I can fill in normal integers 34, and I move is of which type. It's still a tuple. Okay, so if I print it out, I'm printing out T3. I have the 4 of them. Okay, so the last one in sequences is what we call the list. A list is an ordered sequence of 0 or more object references. An empty list is created by using an empty square bracket. Alright, so just the way we created a tuple, if I want to create a list this time, let me say L1, and I assign it into just this square bracket, and you see it's of data type list. L1 is of data type list, as you can see it here. So when you find a data in between a parenthesis, it's going to be a tuple. Then if it's a square bracket, then it's a list. As simple as that. Just the way we fill in values, this 1, 2, and 3 inside the tuples, we can still do inside the list. So if I have another list, L2 equals to, remember this time, square bracket, then inside I start filling in my values. Let me say love here. So I have this list with values love 12, 56, 78, and coming. So if I go ahead and check the type, you see definitely L2 is gonna be a list. Okay, so when I print it out, L2, I still have a list printed out. So now one might ask, what is then the difference between a tuple data type and a list data type? Well, you have a lot of differences, but remember I said I want to keep things simple. But one of the major differences is that a list is mutable. So it's mutable in the sense that you can add items to the list, and you can as well delete items from the list. While a tuple is not mutable, it's just like read only. You can add things up. Maybe here I have a tuple T2 that contain 1, 2, and 3. I can't say, okay, later on I want to add on 4, or later on I want to remove 2. So it's there and it's there. But if it's a list, I can decide to say I want to remove love and add hatred. I want to remove 12 and add 100. So list is kind of flexible. So in Python, you say is mutable. That is the major difference between the two. So depending on what you're creating or the kind of application you are creating, it might require a tuple or a list. Okay, having said that, we'll move on to the next data type, which is the set data type. If you've ever been taught a branch of mathematics called set in school, you will agree with me that a set is an unordered collection of unique items. Python's set data type is an unordered selection of 0 or more object references that refers to hashable objects. Oh, well, I'm saying so many things right now, but for now, just know that all the immutable data types like strings, int, float, tuples, and are all hashable, while the mutable inbuilt data types like lists, the one we just came across now, they are not hashable. We have a video dedicated to hashable and non-hashable data types, so don't worry about that now. To create an empty set, we call the set function. So what I just created is an empty set. Like if I check the type, you see that it's of type set. This is x1. Okay, so this line of code here created an empty set except without an item. That is an empty set. To create a set with one or more items, we use the curly bracket. For example, if I create another set x2 equals to, this time I use a curly bracket, then in between I fill in values where I can say 8, stuff like that. So this is x set. Okay, so I'll go ahead and hit enter. Nothing happens. And if I check the type of x2, you see it's a set. Okay, so if I go ahead and print like before, x2 you see I have the set printed out in curly brackets. Note that set itself is mutable. Okay, so just like list is mutable, you can add up things to the set and you can remove things from the set. But it has this property: one, it is unordered, so the sequence doesn't matter. Like now, if you observe, x2 have 8 in 78, 27, hover, orange. But when we print it out, you see hover comes first. It follows 78, orange. You know, it wasn't as it was inputted. So that's one of its properties. It is not ordered. And again, it doesn't harbor repetition. For example, if I type this, I'm creating another set now, x3 equality, just like before, we open and close a curly bracket, and now I start filling in values. I have 2. Now I move to the next line and I decide to print out this set to the screen. So it's x3, right? Alright, just see. We have in the sect we have the 2 out, 2 for u, and 4 again. But when we printed that, we have only 1 2 out, 1 4, and u. Now what happens? In set, repetition is not allowed, so there's no room for repetition. Once an element is inside the set, adding another element is safe though, but it doesn't make any difference. So we're just seeing like one element. So each of the elements in a set must be unique. Alright, so the next one is the dictionary type. Now, the dictionary data type indicated by Dict is an unordered collection of 0 or more key value pairs, whose keys are object references that refers to hashable objects, and whose values are object references referring to objects of any type. Okay, so for example, if I type this D1 dictionary and I set it up to an empty set. Sorry, there's a mistake there. D1 equality, there's no equality. Then empty curly brackets. And when I check the type of the data I just created, here D1, you see that is a dictionary, Dict. What we created now is an empty dictionary. So if I type D2, now D2, I will set it to a dictionary. I open and close my curly bracket. Then inside, I will start typing. Just exercise a little patience while I type. So if I give this guy a key, let me say 1. Okay. Now I take a column. I give it the second key. I say 1 is the key. It's my name. Now, comma separable. So what I did here, I created a dictionary with 3 keys: key 1, key 2, and key 3. Then key 1 has a value which is a string, dk. Key 2 has a value which is just a tuple containing some great languages. Okay, this is the value for key 2. Now, while key 3 has another tuple containing just default integers. So the sweet thing is this: if I move down to the next line and maybe I check the type as well, as we've been doing before, is our normal routine, so that we'll be careful that it's an actual Delomo dictionary, so that it's a dictionary. Okay, so if I do this now, maybe I want to print I'm gonna do this. Okay, let's say D2. Okay, then I take my square bracket, then inside I now reference 1, for example, and I move. You see that I've printed the key. So what does it mean? This, to access the values, you use the key and you access it this way. Okay, let me just declare it here. I will say let me say D11 is equal to D2, open and close my square brackets, and I pick 2. Okay, and when I move down and I print this variable to the screen, which is D11, you see that I've printed the languages. So that means I accessed this key here using what? this line of code, which is D2, and I access the key. And what does this key contains? The values here. And when I print out this key, it simply prints out the values. So just take your time and go through dictionaries, you understand what is happening. So the same way, if I decide to print out the same one, which is D2, open and close my square brackets, 3, it prints out the numbers. Note that only hashable objects can be used as dictionary keys. For example, if you watch here, the keys is 1, 2, 3. I just use default integers. You can use strings, you can use tuples as well. Alright, so and finally, the last but not the least, the Boolean data type. Python has a bool data type which has only two values, true and false. So for example, here if I say let's say God is equal to true, then I move down and I say devil is equal to false. I hope you understand. So if I say okay, type of God is a variable, okay, it gives me bool, right? And if I still say type of devil, D, it still give me bool. Okay, so that means true and false, they have Boolean type. Okay, so also be mindful of the capital letter T and F. So if you watch the true, it's capital letter T here, and if you watch the false, it's capital letter F. So it's not the same thing when you say true. If I try saying something like true, maybe I say F1 equals to true. I'm trying to assign a truth value to it, and you see when I hit enter, it throws an exception saying that the name true is not defined. Of course, not defined. So in Python, it's case sensitive. If they say it's capital letter, give them capital letter. If it's small letter, go ahead and give them small letter. So it's very much case sensitive. Do you understand? So one thing about bool value is that it has this kind of resemblance with the integers 0 and 1. For example, if I say A is equals to 1, okay, then maybe A1 is equal to true, truth value. Now if I say this, is A equal to A1, you see it gives me a Boolean true. Okay, I hope you understand. So it evaluates true, and for now this means equality, and I'm saying something, an operator that means equality in Python. If you want to make some comparison, this equal to this, remember this one is assignment, this one is equality sign. Okay, so it evaluates true, so that means 1 is actually true. So in live programming, you can use 1 in place of true. It works very well. So if I still do B and assign it default integer 0, and here B1, I call it false. Okay, and I try to text is B equal to B1, is still true. So that means 0 is false, 1 is true. Okay, so alright guys, that is Python 3 data types for you. Thank you for joining us, and see you in the next class.